This animal shouldn't be real.
It lives its life on the knife's edge of what seems possible, in a place where the rules of gravity feel more like a gentle suggestion.
Just look at that.
A creature that can weigh as much as a large person, casually perched on a ledge that seems impossibly narrow, hundreds of feet in the air. This isn't a camera trick. This is the mountain goat, and this is just another Tuesday for them. Most animals run from their predators. They hide, they fight, they camouflage. The mountain goat has a different strategy. It simply goes where nothing else can follow. It treats the sheer, vertical faces of the world's most unforgiving mountains as its personal fortress. But that raises a huge question.
How?
How does a 200-pound mammal cling to near-vertical rock as if it has hooks for feet? The answer isn't that they break the laws of physics.
Instead, they've mastered them.
It's a story of evolutionary genius, a masterclass in biomechanics that has engineered the perfect climber. It all starts with the feet.
At first glance, a mountain goat's hoof looks simple, almost disappointingly so.
It's small, split in two, and seems completely unsuited for the death-defying feats we see. But this simple design hides one of nature's most sophisticated climbing tools. It's a multi-part system that combines the best features of a professional climbing shoe with the adaptability of a robotic hand. If you were to design the perfect climbing foot, you'd probably end up with something that looks a lot like this. To really get it, we need to break it down into its two key parts, each playing a critical role in this high-stakes performance.
First, let's talk about the hoof structure.
It's cloven, meaning it's split into two independent toes, and this split is the first secret to its success. Unlike the solid hoof of a horse, these two toes can move on their own, spreading apart or pinching together. Think about trying to stand on an uneven rock in a flat-soled shoe. You'd wobble, making contact in just a few spots. But the mountain goat can splay its toes, essentially molding them to the contours of the rock, which maximizes its contact area and creates a much more stable platform. If one toe starts to slip, the other can hold fast. A critical backup in a world where a single mistake can be fatal. It's like having two tiny, independent hands on the end of each leg, constantly adjusting and gripping. The outer edge of each toe is made of a hard, sharp rim of keratin, the same stuff as our fingernails, but way tougher. This edge works just like the stiff, aggressive edge on a high-end rock climbing shoe. It's designed to bite into the smallest imperfections in the rock. Micro cracks, tiny crystals, and ledges so small we'd barely notice them. This hard rim is the anchor, the point of precision that lets the goat use holds that most animals, including human climbers, would write off as impossible. But a hard edge isn't enough, especially on smoother surfaces where there's nothing to grab onto. This is where the second part of the system comes in. Inside that hard, keratin rim is a soft, fleshy, textured pad.
This inner pad is pliable and rubbery, with a rough texture that functions like the soft rubber on a climber's smearing shoe.
When the goat put its weight down, this soft pad squishes down and molds itself perfectly to the rock's surface. At a microscopic level, this massively increases the surface area in contact with the stone, generating an incredible amount of friction. It's the difference between trying to grip a smooth table with a hard piece of plastic versus a soft piece of rubber. The rubber deforms, filling every tiny gap and maximizing grip. This two-part design is genius. The hard outer edge provides the mechanical lock, hooking onto features, while the soft inner pad provides the friction, sticking to the surface like a high-performance tire. It's a system that works on both rough, jagged rock and on smooth, sloped faces. What's more, this internal pad also acts as a shock absorber. When a goat leaps from one ledge to another, which they can do over impressive distances, the pads compress, soaking up the immense impact forces. And the system is even more dynamic. The goat has sharp dewclaws, smaller digits located higher up the leg. These act as an extra braking system, especially during steep descents, digging into the ground or snagging on rocks to provide another layer of security. When you put it all together, the independent toes, the hard biting edge, the soft friction pad, and the dewclaw brakes, you don't just have a hoof. You have a piece of high-performance biomechanical equipment that's perfectly adapted to its environment. But as any climber will tell you, the best shoes in the world are useless without the body to power them. The hooves are the contact points, but the real force that propels this animal up a vertical world comes from its uniquely built body. This isn't just an animal with good feet, this is an animal that is, from head to toe, a climbing machine.
One of the most noticeable features is its powerful build, particularly its muscular shoulders and neck.
While animals built for running on flat ground often have their power concentrated in their hindquarters, the mountain goat has incredible strength in its front end. That's because climbing is fundamentally a pulling motion. While the back legs push the body up, it's the forelimbs that do a lot of the heavy lifting, pulling the torso upwards and holding it close to the rock face.
Biomechanical studies suggest that goats use a specific two-phase technique when climbing.
First, there's the push-off phase, where the powerful hind limbs extend to propel the body upwards.
Then comes the crucial pull-up phase.
In this motion, the goat uses its immense shoulder strength to perform what is essentially a pull-up. It's an incredibly effective way to turn muscle power directly into vertical gain.
This brings us to the next key component, the goat's center of mass.
For anything on a slope, stability is all about keeping your center of mass over your base of support. A tall, narrow box tips over easily. A low, wide one is much more stable. The mountain goat is the low, wide box. They have a stocky build with relatively short legs for their body size, and their center of mass is positioned low to the ground and forward. This low, forward center of mass gives them a huge stability advantage. As the goat climbs, this forward weight distribution naturally makes it lean into the mountain, which helps prevent it from tipping. It's a passive stability system built right into its anatomy. They aren't defying gravity, they're expertly managing it, keeping their weight planted firmly over their tiny footholds. Their joints also contribute to this incredible stability.
A goat's joints have an unusually large range of motion, allowing for extreme flexibility.
This means each leg can adapt its length and angle independently, letting the goat stand perfectly stable even when all... Imagine trying to set a four-legged table on a jumble of rocks. It would wobble like crazy.
The mountain goat, in real time, adjusts each of its four legs to create a perfectly stable platform, no matter how uneven the ground.
We have this biomechanical masterpiece, a perfect fusion of specialized hooves and a purpose-built body. But this brings up the most important question: why? Why evolve such an extreme and dangerous-looking specialty? The answer has nothing to do with a love for the view. The reason the mountain goat has mastered the mountains is for the oldest reason in the book: survival. The high-altitude world a mountain goat calls home is brutal, but it offers one thing the lush valleys below do not: safety. The main predators of mountain goats include animals like bears, wolves, and cougars.
Down on flat ground, a goat would be pretty vulnerable.
It's not the fastest runner or the fiercest fighter. But on the cliffs, the tables turn. These predators, for all their power, simply can't follow. The steep, rocky terrain that a goat navigates with ease is a death trap for its enemies. This escape terrain is the goat's ultimate fortress.
Goats know this, and they tend to stay close to the safety of the cliffs, even when they're eating.
When threatened, they don't run away, they run up. The near vertical cliffs become their sanctuary. This is why you see them resting on ledges that look impossibly precarious. To us, it's a place of extreme danger. To them, it's the safest place in the world.
Young goats, called kids, are a testament to how deep this strategy runs.
They can start climbing with their mothers when they are just days old. This isn't just playing around, it's a critical life skill being taught from birth. But predator avoidance isn't the only reason they take to the cliffs. There's another, stranger motivation: minerals. Mountain goats are herbivores, but their high-altitude diet is often low in essential minerals like salts and calcium.
As a result, they are powerfully drawn to natural mineral licks, exposed cliff faces where mineral-rich water seeps out of the rock.
They'll cling to these wet, slippery surfaces, licking the minerals directly from the stone. This also explains those famous, mind-bending images of goats clinging to the near-vertical face of a huge dam in Italy. But here's a fun fact: those aren't North American mountain goats. They are their European cousins, the alpine ibex. While they're a different species, they face the same challenges, and evolution has given them a very similar solution: cloven, grippy hooves. The ibex aren't trying to be daredevils. They are licking the salt and mineral deposits that have leached out of the concrete. For them, a massive dam wall is just a man-made mineral lick, an irresistible source of nutrients that's well worth the climb. A mountain goat's mastery extends far beyond its climbing skills. To survive year-round in the high alpine, where temperatures plummet and the air is thin, you need a whole suite of adaptations.
Its most obvious feature is that magnificent white coat.
This isn't just for blending in with the snow. It's a highly advanced thermal suit made of 2 layers. The outer layer is made of long, coarse guard hairs. These hairs are thought to be hollow, trapping a layer of air that creates an incredibly effective insulating barrier against brutal alpine winds. Beneath this shaggy outer coat lies a second layer, a fine, dense, woolly undercoat. This provides the bulk of the insulation, trapping body heat so well that mountain goats can withstand plunging temperatures and fierce winds. Their insulation is so good that snow can pile up on their backs without melting. The white color of the fur itself is also clever. While it might seem odd for staying warm, the hairs appear white because they scatter sunlight. It's thought that this allows solar radiation to penetrate through the fur to the goat's dark skin underneath, which is excellent at absorbing heat. So the coat works 2 ways. It stops body heat from escaping, while helping to capture heat from the sun. Their entire body is tuned for life at high altitude. Their circulatory systems are adapted to keep their bodies warm in freezing conditions, and their metabolism is efficient at digestion. Even their social structure is a product of their environment.
After the mating season, adult males often form their own small bachelor groups, while the females and kids stick together in nursery herds.
It's not enough to be a good climber if you freeze to death. It's not enough to be warm if you can't escape a predator. Every system, from their hooves to their hair, from their muscles to their metabolism, works together. It's a complete survival package that allows them to thrive in one of the most hostile environments on Earth. The mountain goat, Oreamnos americanus, is an astonishing creature, but it's not totally unique. When nature faces the same problem in different places, it often comes up with a similar solution. This is called convergent evolution, and the world's cliffs are filled with animals that have independently developed their own versions of the goat's gravity-defying toolkit.
We've already met the alpine ibex, scaling dams in Italy.
Like the mountain goat, its secret is in its hooves, a hard outer edge for ledges and a soft inner pad for friction. Though they belong to a different genus, evolution pushed them toward the exact same 2-part hoof design to solve the same problem: how to stick to a mountain. Or look at the chamois of Europe's mountains, another goat antelope famous for its agility, which also has split hooves with rubbery pads for traction. Each of these species, though distinct, is like a different draft of nature's blueprint for the perfect climber. Comparing them shows us the subtle variations on a winning theme. The North American mountain goat, with its stocky build and powerful shoulders, is a specialist in vertical climbing, a true pull-up artist. Other species, like the ibex, might be more adapted for spectacular leaps between ledges. This convergence is powerful evidence for how effective these adaptations are. The fact that different species on different continents, separated by millions of years of evolution, all landed on the hard-edge, soft pad.
And these designs are now inspiring human technology.
Researchers in robotics are studying the mechanics of goat and ibex hooves to build bio-inspired feet for climbing robots. They're experimenting with flexible joints and smart gripping materials to create robots that can navigate complex, uneven terrain for By studying the mountain goat, we're not just learning about nature, we're uncovering fundamental principles of physics and engineering. The mountain goat is a powerful reminder that the natural world is full of wonders that challenge our assumptions. Its abilities force us to look closer and appreciate the sheer genius of evolution. What other animals do you know of that seem to have their own biological superpowers? Let us know in the comments below. We read every one, and your ideas might just inspire our next deep dive. And if you love seeing how nature solves these impossible problems, consider liking this video and subscribing to the channel. We're dedicated to uncovering the science behind the most incredible stories in the animal kingdom, and you won't want to miss what's next. So the next time you see a picture of a mountain goat standing calmly on a cliff face that looks impossibly steep, you'll know the secrets behind the spectacle.
You're not looking at a reckless animal with a death wish. You're witnessing a masterclass in biomechanical engineering.
You're seeing the product of millions of years of evolution, an animal forged in the crucible of the world's most extreme environments. You'll see the specialized hooves, each one a perfect climbing tool with a hard, biting edge for precision and a soft, rubbery pad for unmatched friction.
You'll understand the engine behind it all. The powerful shoulder muscles for pulling, the low center of gravity for unshakable stability.
And most importantly, you'll know why.
You'll see not just a climber, but a survivor.
An animal that turned the deadliest parts of its world into its greatest defense, transforming sheer cliffs from a hazard into a fortress. It climbs to escape predators and to find the essential minerals that sustain its life. The mountain goat doesn't break the laws of physics.
It has mastered them.
It has bent the rules of gravity, friction, and biology to its will, creating a life in a place where life shouldn't be possible. It is a living, breathing paradox, a symbol of serene confidence in the face of absolute peril,